This question is given in it was given in 2006 AL paper, which is based on Bernoulli's theorem. So write the heading 2006 mechanics first essay question. Write the heading 2006 mechanics first essay question. 2006 mechanics first essay question. Somebody unmute the mic and read the question. Read Roman number 1.
Bernoulli's equation for a fluid flow can be written as P plus half PV squared plus H rho G equal a constant where all symbols have their usual meaning. Apply dimensional analysis only to the term half PV squared. Show that it has the dimensions of the pressure.
Actually, these terms are not P. Actually, that should be it should be rho. These terms should not be P. It should be rho here. This is not P. It should be rho. This one. So this is P. Yeah. This is P. Half, not half PV square. It should be now okay. What are the terms here? P plus half rho V square plus H rho G. It is not P. Here also the same mistake is there. It's not PV square, should be rho. The term rho is used for density. Okay, dear. So apply dimensional analysis only the term half rho V square. Show that it has the dimensions of pressure. Okay, let's give a try. So please remember that this is P. The first term is P. After that, half rho V square H rho G. Rho for density, P for pressure. Right. Let's give a try here. Let's give a try. Right. So this is 2006 AL paper. Essay equation. 2006 AL first essay equation. First essay equation. So they have given Bernoulli's equation. They have given Bernoulli's equation as P plus half rho V square plus H rho G equals a constant. So here P is pressure. P is pressure. The term rho for density. Density of the liquid or density of the fluid. What is the can you find the dimensions of pressure here? Pressure equals, somebody please tell me the equation. Pressure equals force over area. Pressure equals force over area. Am I right? So dimension of force,
yes, sir.
MLT minus 2 area L square. Very good. Dimensions of force MLT minus 2 dimension of area L square. So this is M LP minus 2 divided by L square can be written as L into L. L square can be written as L into L. So one of the L terms can be cancelled out. This divided by L comes up. The division L comes up with a minus sign. So ML minus 1, P minus 2 is the dimension of pressure. We have found, actually in the examination, no need to do it. Here I have done it for you to show it. In the examination, no need to write. So dimensions of pressure is found as ML minus 1, P minus 2. So we should analyze this term. We should analyze this term. The term half rho V square should be analyzed and we should prove that this term rho for density, V for velocity, and square. We should prove that dimension of half rho v square is also equal to ml minus 1 t minus 2. We should prove that dimensions of half rho v square is equal to ml minus 1 t minus 2. Let's write down everything that I have written on the board and try to find the dimensions of half rho v square. Try to find the dimensions of half rho v square. Give a try here. Start. Right. Have you obtained the dimensions here? Half is a number. Half is a number. Numbers do not have dimensions. To say that no dimensions, we write 1. Density, mass over volume. Volume is L3, L to power 3. Velocity is Lp minus 1. We have to get the square, V square. So then M, L to power 3 comes up as L to power minus 3. Square of L square, square of T minus 1. Square of T minus 1 is T minus 2. L to power minus 3, L to power plus 2. M minus 3 plus 2 means minus 1. ML minus 1, T minus 2. Now it is very much clear that ML minus 1, T minus 2 is the dimension of pressure. Therefore, dimension of this term is equal to the dimensions of pressure. To the dimensions of pressure. So in the examination, you should write only the things that I have written in blue color. In the examination, you should write only the things that I have written in blue color. Okay, dear? Start.
Excuse me, sir.
Yes, I am listening.
Sir, what is V, sir?
V is velocity. V is
Okay,
velocity.
sir. Thank you, sir. Okay, sir. Thank you, sir.
Okay, dear. Okay, now let's go to question number 2. Let's go to question number 2. Somebody unmute the mic and read question number 2, dear. Unmute the mic and read Roman number 2.
Figure shows a cross-section of a wing of an aeroplane which is moving through air horizontally to the left at constant velocity v relative to the ground. What is the magnitude and direction of the velocity of air at point x relative to the plane? Assume that air is at rest relative to the ground.
Thank you, dear. Roman number 2, it says, figure shows a cross-section of a wing of an aeroplane which is moving through air horizontally to the left at a constant velocity v relative to the ground. So velocity of the aeroplane is v. What's the magnitude and direction of the velocity of air at point x relative to the plane? They have given a very important thing here. What is it here? It is said that air is at rest. Air is at rest relative to the ground. It means, is there any motion in air particles there? Somebody please tell me, is there any motion in air particles? Air is at rest. So is there any motion? Somebody please tell me.
No, sir.
No motion. Then why do they ask what is the magnitude and direction of velocity of air? It is said air is at rest. At the same time, they ask what is the velocity of air? Why is that there?
Because the velocity has a direction.
No. If air particles are at rest, what is the velocity of air particles here? Somebody please tell me. What's the velocity of air particles in this circle here? Somebody please tell me.
No.
0, because it is given that air is at rest relative to the ground. So velocity of air, the term is relative to the ground. Velocity of air relative to the ground is 0. But what is the velocity of air relative to the aeroplane here? Aeroplane is moving to left with the velocity of v. Can you see this? So
Yes,
it's something
sir.
like this. Let's say you want to ride a bike. You sit, you start the bike, but you do not ride it. Bike is at rest. Then you don't feel any wind. You don't feel a wind. But once you start riding the bike, you will feel a wind. You will experience that wind is moving towards you. Why is that here? Who is actually moving? You or air particles? Lamai?
We, sir.
Yeah, you are moving, but how do you feel? You feel that you feel that air particles are moving. So same thing will happen here. And at the other example is, let's say you travel in bus or car or a van. Then you will see that coconut trees are moving towards you. Who has experienced it? When you travel in a vehicle, if you look at the buildings and trees, you may see that, you may observe that the trees are coming towards you. Are the trees actually moving?
No,
Still,
sir.
trees are not actually moving. Who is moving? Who is moving?
We are moving.
You are moving. But how do you observe them?
The trees are moving.
Trees are moving. So do you observe the reality or not? Huh?
No,
Do you
sir.
observe the truth or do you observe the false?
False.
The observation is wrong, am I right?
Yes, sir.
So relative to the ground, trees and buildings are at rest. Relative to the you, trees and buildings are moving. Same here. Relative to the ground, air particles are at rest. But relative to the aeroplane, air particles are moving towards the aeroplane. So if you ask from the pilot or a person in the aeroplane, that person will tell you that air particles are moving towards them. Aeroplane is moving to the left hand side. Aeroplane is moving to the left hand side. If you ask from a person in the aeroplane, he will say that air particles are moving to the right hand side. With what is the velocity here? What will be the velocity? Namai? If the aeroplane is moving with the velocity of v, what will be the velocity of stationary air particles relative to the aeroplane here?
V.
V. So if you ask a person inside the aeroplane about the motion of the air particles, he will say air particles are moving towards the aeroplane with a velocity of v meter per second. So it is the same velocity as the aeroplane. Is it clear, or may I again explain? Who would like if I explain it again? Anybody in the class? Right, so please write 2006 AL, 2006 AL, Roman number 2, simple equation. 2006, we have started, we have written the heading. This is Roman number 2, simple equation. So please write velocity of air particles relative to the aeroplane. Velocity of air particles relative to the aeroplane is v meter per second into the right hand side direction. Velocity of air particles relative to the aeroplane is V meter per second into the right hand side direction. Velocity of air particles relative to the aeroplane is V meter per second into the right hand side direction. Right. Then let's go to the next question. Roman number 2, simple B. Right. Somebody unmute the mic and read Roman number 2, simple B. Somebody unmute the mic and read simple B question. Start.
As shown in the figure, the cross-sectional area of a tube of flow exists away from the wing is A1, and the corresponding area of the same tube of flow over the top of surface of the wing is A2. If A1 divided by A2 equal 1.2, write down an expression for the speed V of air passing over the top surface of the wings relative to the aeroplane in the terms of V.
Thank you, dear. So it says, as shown in the figure, the cross-section area of tube of flow. Tube of flow. It means you can imagine that. Aeroplane is moving in an imaginary air tube while flowing. It can be imagined that aeroplane is moving in an imaginary, moving through an imaginary air tube. From the wing is A1. So here the cross-section area A1, and here the cross-section area of the imaginary air tube is A2. So all these lines A1, A2 represents an imaginary air tube. I'll explain it. The question asks us to find the velocity of air particles at A2, at the cross-section A2. They have given the relationship between A1 and A2. A1 divided by A2 is given as 1.2. A1 divided by A2 is given as 1.2. Velocity of air at this point at A2 is given as V dash. Let me draw this figure here. It will be easy if I draw the figure and explain. Let me draw it. So here we can imagine, it can be imagined that there is an imaginary air tube. So this is a tube of air. It is a tube of air. Like this. Right? This is a tube of air. What will happen when aeroplane enters into this tube here? So aeroplane, the wing of the aeroplane has this kind of a shape. When the aeroplane moves into the imaginary tube, this is an imaginary air tube. An imaginary air tube. Right? So when the aeroplane enters to the imaginary air tube, air particles here, the particles of air here collide with the wing. Those air particles collide with the wing, and air tube will be bent. It will be bent like this. Look at what, when this wing enters to the imaginary air tube, right? These air particles will be bent. They will be bent like this. So that's what happened. Can you understand? So this is what happened when the wing enters to the imaginary air cylinder. Right? So this is an imaginary air tube. The cross-section area of the air tube here is given as A1 square meter. The cross-section area of the same air tube here is given as A2 square square meter. The velocity of the aeroplane into this direction is v meter per second. The point x is here. Point x is here. So if aeroplane is moving to this direction with the velocity of v, if the aeroplane is moving to this direction towards me with the velocity of v, the people inside the aeroplane will observe that air particles are moving towards the aeroplane with the same velocity of v meter per second. So if I mark it as v1, v1 is equal to v meter per second. Can you understand it? Air particles are really at rest. They are really at rest, but they will be moved when the aeroplane is moving like this, but through this imaginary air tube, the aeroplane will experience a wind. Something like when we ride a bike in a stationary air, when we ride a bike in stationary air, we feel that a wind flows over our body. Similarly, when you travel in a vehicle, if you open the window, you feel that a wind is passing through you. Actually, we are moving through the air particles, but we experience that air is moving through us. It is an artificial wind. So same thing will happen here. I want to mark a special point here. Actually, point x is somewhere here. I would like to draw another line. This line will be needed in future. This is point x. Let me mark this as point y, and let me mark this as point z. These things will be needed in future. That's why I have marked. Pressure of air here. Let me mark it as P1 Pascal. So, and pressure of air here also P1 Pascal. Pressure of air here also P1 Pascal. And pressure of air at the point x is also P1 Pascal. All of these points, x and all the points are in the same atmosphere. They are in the same atmosphere and they are closer to each other. Therefore, pressures at all these points should be the same P1. And again, x, y, z points are on the same horizontal line in the same atmosphere. They are actually at rest relative to the ground. All the points here are at rest relative to the ground. All of them are in the same atmosphere. Therefore, pressure at y is also P1 Pascal. Pressure at z is also P1 Pascal. So all the points are in the same atmosphere. All of these points are at rest relative to the ground. Therefore, all those points will have the same pressure. All of those points will have the same pressure. Can you understand here? All of those points will have the same pressure. But here, due to the bending of the imaginary air tube, you see the velocity is changed. So velocity of air particles here and the velocity of air particles here. So if I mark this as W, if I mark this as point W, right? The point W, velocity of air particles at the point W and the velocity of air particles at X are not equal. So they may have a different velocity, something like V2. In the exam, they have given this V2 equals V dash meter per second. Due to the change in velocity, even they are in the same atmosphere, the velocity of these air particles are not equal. Therefore, pressure of air particles at X is not equal to the pressure of air particles at W. So pressure of the air particles at the point W, let me mark it as P2 Pascal. You need these descriptions to answer the question fully. And the other thing, it's better if you draw a ground also. It's better if we draw a ground also. This is the ground. This is the ground. You need these explanations here. And this height. Let me mark this height as h1 meter and let me mark the other height, this height, as H2 meters. Got it? So please draw the complete figure. You need such a complete figure to answer the questions. So once we draw a complete figure at the very beginning of the question, it will be very easy for us to answer the question. If we draw half of a figure, again and again we have to draw the figures. Now I have drawn a complete figure we can use until the end of the question. Start, draw it. While you are drawing, if you have any difficult point, if you think anything is difficult, just unmute the mic and ask. Start here.
Sir, relative to the ground, V2 also 0, right?
Yes, I'm listening there. Please ask the question again.
Sir, relative to the ground, V2 also 0, right?
Again.
Sir, can you hear me, sir?
Yeah, I can hear you speak loudly, dear.
Okay, sir. Sir, relative to the ground, V2 also 0, right?
V2 is not zero. You see, air particles collide with the aeroplane. Due to such collisions, velocity and the change of the, you see, cross-section area of the RTUP is changed. Due to the change in the cross-section area, V1, it means V1 has this V1 is the velocity of air particles relative to the aeroplane. Similarly, V2 is the velocity of air particles relative to the aeroplane. Now we do not worry about the velocities relative to the ground. We worry about the velocities relative to the aeroplane. Got it? So therefore, even
Yes.
V1 is not zero relative to the aeroplane. V2 is not zero relative to the aeroplane. Relative to the aeroplane, V1 is equal to the velocity of aeroplane. V2 will be definitely be greater than the velocity of aeroplane relative to the aeroplane. May I
Yes.
explain it again?
Thank you. So that means V2 has a velocity relative to the aeroplane, but relative to the ground, it is still 0, no?
Yeah, relative to the ground, air particles are at risk. It's something like this here. When you ride a bike, actually air particles are at risk. But how do you feel?
We feel like air particles
Feel
are
the
moving
wind, right?
towards us.
Feel a
Yes,
wind.
sir.
You feel that the wind flows over your body. The same happens in the aeroplane here. Okay, dear?
Yes. Okay, sir. Thank you.
Okay, right. Right. In simple B equation, it is asked us to write down an expression for this velocity V dash. So to this flow tube, this imaginary air tube, let's apply the equation of continuity. What is the equation of continuity here? A1 B1 equals A2 B2. Let's apply the equation of continuity to this flow tube. A1 is A1, B1 is B. This is A2 into A2. If I take A2 to this side by cross multiplication, if I take A2 to the other side by cross multiplication, this will be A1 into V divided by A2 equals V. Therefore, V2 equals A1 over A2. A1 divided by A2 into V. V2 equals A1 over A2 given in the question. A1 over A2 is given as 1.2. A1 over A2 is given as 1.2. A1 over A2 is given as 1.2 times V. Let me mark this as the first equation. But here they have given that V2 equal V dash. I have marked this as the first equation, but they have given V2 as V dash. Therefore, to earn marks, we should write one more step. V2 is V dash. V dash equals 1.2 times V. I have kept this equation for my future uses. I want to use this relationship in future calculations. So I have named it as the equation number 1. And I have written this step to earn marks. Can you understand here? Complete it. Right. Let's go to next part of the question here. Let's go to the next part. Somebody read simple C question here. Somebody unmute the mic and read simple C question. Start.
If the plane has a mass of 2.64 into 10 to the power 5 kilogram and total effective surface area of both wing is 250 meter squared, calculate the minimum value of V necessary for the aeroplane to just lift off the ground. Bracket, the density of the air is 1.20 kilogram minus 3 to the power minus 3.
Very good. Very good. Here V is the velocity of the aeroplane. If the velocity of the aeroplane is V, when the aeroplane is moving, in stationary air particles, aeroplane experiences a wind with a velocity of V meter per second. So what's the theory here? When the aeroplane is moving in air, actually air particles are at rest. But when the aeroplane moving in air, through the air, with the velocity of V, the aeroplane will experience a wind with the velocity of V. Clear? Then let's try to obtain this expression. But before that, for simple C, let's write some descriptions. For simple C, I want to write some descriptions here. If the velocity of aeroplane is V, the velocity of the wind observed by the aeroplane is also V. But due to the bending of this imaginary air tube, the velocity of air particles here will be greater than V. So I have marked it as V2. In the examination, V2 is given as V dash. So I want to write few more things. Please write the air particles at x, y, z. C. Under that, please write some points, star points. In the examination, no need to write these star points, but it's better to write the star points now for you to understand. If you write these star points, it will be a big help for you to understand the question completely. So put some star points and write air particles at x, y, z. The air particles at x, y, z are at the same horizontal level in the atmosphere. The air particles at x, y, z are at the same horizontal level in the atmosphere. Full stop. The air particles at x, y, z are at the same horizontal level of the atmosphere. At the same horizontal level of the atmosphere. Therefore, at the same horizontal level of the atmosphere, full stop. Those air particles are at rest relative to the ground. Those air particles are at rest relative to the ground. Those air particles are at rest relative to the ground. Leave a line and write, because of the above two reasons, the pressure at x, y, z, the pressure at x, y, z, because of the above two reasons, the pressures at x, y, z, the pressures at x, y, z will be the same. Pressures at x, y, z will be the same. Pressures at x, y, z will be the same. Pressures at x, y, z will be the same. So leave a line and write, therefore Px, Py, Pz. Px equals P1 Pascal. Py equals P1 Pascal. Pz is also P1 Pascal. Use a curl bracket and mark it as the second equation. First equation is this, and mark this as the second equation. Start there. Write them. X comma Y comma Z are at the same horizontal level in the atmosphere, and all the 3 points are at rest relative to the cloud. Their velocities are equal, they are rest. They are at the same horizontal level in the same atmosphere. Therefore, Px equal Py equal Pz equals P1 Pascal. Next star point. When the aeroplane moves through the imaginary air tube, when the aeroplane moves through the imaginary air tube, when the aeroplane moves through the imaginary air tube, comma, the cross-section area of the imaginary air tube is changed, is reduced. When the aeroplane moves through the imaginary air tube, when the aeroplane moves through the imaginary air tube, comma, the cross-section area of the air tube is reduced. The cross-section area of the air tube is reduced. Then the velocity of air, then the velocity of air and pressure of air, then the velocity of air and pressure of air are changed, Then the velocity of air and pressure of air are changed. When the aeroplane moves through the imaginary air tube, the cross-section area of the air tube is reduced. Then the pressure of air and velocity of air and pressure of air are changed. Here I have marked it as V2 and V2. So within brackets, please write within brackets V2 and V2. Within brackets, please write V2 and V2. V2 and V2. So whether you write these star points in the examination or not, no marks will be given. That's not necessary. The third and last star point. The third and last star point. It can be assumed that H1 simple H1 height and H2 heights are approximately equal. You just check the figure. If you check the figure, it can be observed that it can be assumed that H1 and H2 heights are approximately equal. It can be assumed that H1 and H2 heights are approximately equal. It can be assumed that H1 and H2 heights are approximately equal. It can be assumed that H1 and H2 heights are approximately equal. Look at board. Look at board here. So therefore, please write the next equation. H1 equals H2. H1 equals H2. Mark this as the third equation. Mark it as the third equation. Start here. Start. Now we are going to apply Bernoulli's equation from to the imaginary air tube from X to W. Leave a line and write, let us apply Bernoulli's equation. Let us apply Bernoulli's equation to the imaginary air tube. Let us apply Bernoulli's equation to the imaginary air tube. To the imaginary air tube from X to W. From X to W. Let us apply Bernoulli's equation to the imaginary air tube from X to W, from X to W, let us apply Bernoulli's equation to the imaginary air tube from X to W, from X to W. Look at board. Look at board. Bernoulli's equation P1 plus half rho V1 square plus rho GH1 equals P2 plus half rho V2 square plus rho GH2. So pressure here is P1, pressure here is P2, no problem. Velocity here V1, velocity here V2, no problem. Height is H1, height is H2. So what do you think about this rho GH1 and rho GH2 terms here? If H1 and H2 are approximately equal, what do you think about H1 and H2 here?
Equal.
They will be cancelled out. I can show it easily next in the next step. I'll take P2 to this side. P1 plus half rho V square plus rho GH1 plus rho GH2 comes this side as minus rho GH2 plus P2 comes this side as minus P2 equals half rho V2 square. So what have I done there? I have taken both rho GH2 and P2 to the other side. I have taken both rho GH2 and P2 to the other side. Then rho GH1 and rho GH2 cancel it out. So next step, I can write P1 minus P2 equals half rho V2 square. And see, I'll take this term, half rho V1 square here. Can you understand here? Rho GH1, rho GH2 cancelled out. Half rho V1 square is taken to this side. Plus half rho V1 square comes to this side as minus half rho V1 square. Then P1 minus P2 equals half rho common. So I'll take half rho out from a bracket. The remaining terms will be V2 square minus V1 square. So let me mark this as my 1, 2, 3, 4 equation. Yeah, maybe equation number 4. Write it here. Write them. Right, I'm going to erase everything that I have written on the board. So if you want, please take a screenshot. If you want, please take a screenshot. I'm going to erase everything. Right. Star point and right. Star point and right. Due to the pressure P1 at Y, due to the pressure P1 at Y and the pressure P2 at W, due to the pressure P1 at Y, due to the pressure P1 at Y and the pressure P2 at W, due to the pressure P1 at Y and P2 at W, comma, forces are formed on the aeroplane. Forces are formed on the aeroplane due to the pressure P1 at point Y, due to the pressure P1 at Y and pressure P2 at W, forces are formed on the aeroplane. Forces are formed on the aeroplane. Forces are formed on the aeroplane. Full stop. Those forces are known as pressure forces. 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 Full stop. Effective surface area. Full stop and continue. Effective surface area for the pressure forces. Effective surface area for the pressure forces for both wings. Effective surface area for pressure forces for both wings. Comma, both upper and lower surfaces. Both upper and lower surfaces. Both upper and lower surfaces. Comma, given as 250 square meter. Given as 250 square meter. Given as 250 square meter. Right. So because of the pressure, look at what, because of the pressure, let me erase. Because of the pressure at Y, because of this P1 Pascal pressure, a force is formed on the aeroplane. We can write them later. And similarly, because of the pressure at W, that pressure is P2 Pascal, another force is formed on the aeroplane. Let me mark those forces as F1 Newton and F2 Newton. F1 Newton and F2 Newton. In addition to these F1, F2 Newtons, there will be the weight of the aeroplane, mg Newton. Draw this figure and somebody unmute the mic and read the note that I have given for this. Draw this figure. At the same time, somebody unmute the mic and read the note that I have given for this. Start.
Due to the pressure P1 at Y and P2 at W, forces are formed on the aeroplane. Those forces are known as pressure forces. Effective surface area for the pressure for both wings, both upper and lower surfaces, given as 250 meter squared.
Tell me.
Due to the pressure P1 at Y and pressure P2 at W, forces are formed on the aeroplane. Those forces are known as pressure forces. Effective surface area for the pressure forces for both wings for both upper and lower surfaces given as 250 meters squared.
Okay, thank you, dear. Right. Now we know that pressure at the lower surface is P1 Pascal. Pressure acting on the upper surface is P2 Pascal. The fourth equation gives us the relationship between P1 minus P2. So when there is a pressure, there is a force. Am I right, dear? Am I?
Yes, sir.
Yeah. So we know that pressure equals force over area. We know that pressure equals force over area. So if I take, look at board, if I take area to the other side, I will obtain an equation something like this. Pressure into area equals force. Is this clear here? So from this equation, we can prove that if I take area to the other side, I will obtain an equation that pressure times area equals to force. Is it clear for all? Lamai?
Yes, sir.
Okay, please write this, dear. Please write this. Right. After that, star point and right. Star point and right. Due to the pressures P1 and P2, due to the pressures P1 and P2, due to the pressures P1 and P2, two forces are formed on the upper surface and the lower surface of each wing. Due to the pressures P1 and P2, forces are formed on both upper surface and lower surface of both wings. Forces are formed on both upper surface and lower surface of both wings. Right. So I have named those two forces as F1 and F2. So simply I can find F1, look at board. The force F1, I have used capital letters for them. F1 should be equal to pressure into area. Right. So what is the pressure acting on the bottom surface? F1 is the force due to the pressure acting on the bottom surface. What is the pressure acting on the bottom surface, Lamai? Somebody unmute the mic and talk to me, dear. What is the pressure acting? What is the letter? What is the term that we have used for the pressure acting on the bottom surface?
Sir, it's lagging, sir.
Can't you hear my voice properly? Is it okay now or not okay?
Now, okay, sir.
Now okay, right? I asked you that, right? What is the term that I have used for the pressure acting on the bottom surface?
P1.
Pressure acting, pressure, dear.
P1, sir.
P1, very good. So pressure acting on the bottom surface is P1. What is the cross-section area of the bottom surface?
250.
250. So let me use the letter capital A for the pressure, letter capital A for the cross-section area. And let me keep it like this, dear, because then I can save the space, right? Then what about F2, dear? The force F2 equals again pressure into area, right? So what is the pressure, dear? What is the pressure acting on the top surface of each wing?
P2.
That is P2. Cross-section area, let me use A because they have said effective surface area for both upper surface and lower surface is capital A. It's clearly given. Am I right, dear? Right. Please write the expressions for both forces F1 and F2, dear. Quick. Normally for a pressure force, the surface should be flat, but you see that the upper surface is not flat. It's a curved surface. Can you see this there? The upper surface is curved. Therefore, we don't know how to calculate the pressure surface for a curved surface. Therefore, in the exam, they have said that even for the upper surface, use the area for the pressure force as 250. So that is said to be the effective surface area. So we should not worry about the curved surface. The perpendicular pressure force acting vertically downward on the upper surface is F2. To calculate F2, they have given us the effective surface area by neglecting or by calculating the perpendicular component. So which is known as the effective surface area. So we should not worry about the curved section of the surface. Okay, dear? Lamai?
Okay, sir.
Right. Then let's go to the next thing. So what is the meaning of just lift off, dear? What's the meaning of just lift off? Lamai? Who knows the meaning of just lift off? They ask us to calculate the velocity of the minimum velocity needed for the aeroplane for it to just lift off. Right. The meaning of, put a star point and write. When the aeroplane is slowly moving upward with a zero acceleration. When the aeroplane is slowly moving upward with a zero acceleration. With a zero acceleration. Comma. Comma. It is said that aeroplane is just lift off. It is said that the aeroplane is just lift off when the aeroplane is slowly moved upward with a zero acceleration. It is said that the aeroplane is just lift off. Okay, dear? Did you all write it? Did you all write it?
Yes, sir.
Right. How many forces acting on the aeroplane, dear? Actually, wing of the aeroplane. Consider the figure and tell me the number of forces acting on the wing, each wing, dear. I have marked them.
3.
3 forces, F1, F2 and mg. Very good. F1, F2 and mg. Very good. So please write 3 forces are, leave a line and write 3 forces are acting on the aeroplane. 3 forces are acting on the aeroplane. Within brackets, F1, F2 and mg. 3 forces are acting on the aeroplane. Within brackets, F1, F2 and mg. Okay, dear? Right. So
Okay, sir.
the simplest thing that can be done is, right, leave a line and write. Simplest thing means actually I'm going to apply F equals m. That is the simplest thing. So just lift off mean moving slowly up with a zero acceleration. So if I apply F equals ma, A is 0. Right. So please write, leave a line and write, let us apply F equals ma to the aeroplane vertically upward. Let us apply F equals ma equation to the aeroplane vertically upward. Right. Now I'm going to apply F equals ma equation. Look at board. Right. I'll just erase them because we have written all these things. Let us apply F equals ma equation vertically upward. Right. So if we apply F equals ma equation, how many forces are acting vertically upward here? Just look at board and tell me. How many forces acting vertically upward?
1.
Yes, only one force. Yes, very good. Only one force is acting vertically upward. That is F1. F2 and mg acting vertically downward. So if I try to apply F equals ma equation, the force F1 acting upward, the force F2 and mg are acting downward. F1 acting upward, F2 plus mg acting downward. Therefore, what is the total upward force there? The total upward force is upward force F1 minus summation of the downward forces. Upward force minus summation of the downward forces is the total upward force. Right? Equals ma, mass is m. What is the acceleration? Somebody please tell me the acceleration, dear.
0.
0. So F1 if I remove the brackets, minus into F2 minus F2. See the beauty? Minus into F2 minus F2. Again, what is this minus sign into plus sign there? Minus into plus, somebody?
Minus.
That is minus mg equals, what is 0 into anything there? 0 into anything? Lamai, 0 multiplied by anything? 0 multiplied by, yes, why not? 0 multiplied by anything is 0. Now let me take minus mg to the other side, so it will go to the other side as plus mg, right? So this side I have f1 minus f2 minus mg goes to the other side as plus mg. Is it clear for all, Lamai?
Yes, sir.
Now just look at this blue color equations here. What is f1 according to this blue color equation? What is f1?
P1A.
P1 into capital A. F1 is P1 into capital A. What is F2 dear?
P2 into A.
P2 into capital A equals mg. Now you should identify that capital A is common. They have said effective surface area for the pressure force is 250. Actually A is 250. If you want, you can write it also. Capital A is 250 square meter. That is given in the question, saying effective surface area for the pressure force, right? So now we should identify that capital A can be taken out. This A and this A can be taken out from a bracket. So let me take it out. So I'll get the equation like this. P1 minus P2 times capital A equals mg. Okay, dear? Lamai, is it clear?
Clear, sir.
Right. Now, thank you very much. Now I'll take this capital A to the other side. The multiplication capital A goes to the other side as division. P1 minus P2. Multiplication capital A goes to the other side as division capital A. So finally I'll get an equation. P1 minus P2 equals mg minus capital mg divided by capital A. Let me mark this as equation number 5. Am I right there? Equation number 5, we have written up to 4. Yes. Yeah, we have written up to 4. So this should be equation number 5. Please write there. Please write this. Everybody please write. And if you have any doubt, you can unmute the mic and ask. Start. Please send me a message to Zoom chat saying done once you have written all these things. Okay. Once you have written up to the equation number 5, please send a message to Zoom chat saying done. Who wants more time to write these things, dear? Equation number 5. Who wants more time? May I erase it and may I go to the next section? If you want any more time, please raise your hand up in the Zoom chat. Okay, until others are writing the equation, somebody tell me the equation number 5, dear. Equation number 4. What is equation number 4, dear? Somebody please tell me. Somebody unmute the mic and read equation number 4.
P1 minus P2 equals half rho V2 squared minus V1 squared.
Very good. P1 minus P2 equal half rho into V2 square minus V1 square. And what is the first equation here? Somebody please unmute the mic and tell me what the third equation number 1 is. It's still on the board. What is equation number 1?
V2 equals 1.2 V.
V2 equals 1.2 times V. Actually, V2 equals 1.2 times V1. It should be V1. V2 equals 1.2 times V1. Am I right, dear? What is V2, dear? What is V1? Actually, V1 is the velocity of the aeroplane, right? Okay, now I'm going to do something like this. Look at board. Let me keep it here. Right. Okay. Still, I think you are able to see the equations. Now I'm going to do something like this. I'm going to combine equation number 1, equation number 4 and 5. What am I going to do? This is equation number 1. I'm going to combine, look at board carefully. I'm going to combine equation number 1, 4 and 5 from the equation number 1, 4 and 5. I'm going to use them. I'm going to use the equations, right? Equation number 4 tells us P1 minus P2 equals half into rho. I write the rho like this because that's how it types, right? So I have to write the rho like this. Half into rho into V2 square. How do I write it? V2 square minus V1 square. Am I right there? But according to equation number 5, this is equation number 4. You see, P1 minus P2 equal half rho V2 square minus V1 square is the equation number 4. But according to equation number 5, P1 minus P2 is mg over A. Mg over A. So in the place of P1 minus P2, let me write mg over A according to equation number 5. So let me write here mg over capital A equals half into rho, that is the density of air actually, into V2 square minus, V2 square minus V1 square. Okay, dear? Right. Button, look at board. Wait one more minute. Button, this time, this term not change. Mg over A is not change. Equals, look at board carefully. Half into P into, now, what is V2, dear? According to equation number 1. If you want, I can show you equation number 1 here. Now look at board. What is equation? What is V2 according to this red color equation? Equation number 1. Somebody unmute the mic and tell me.
1.2 V1.
1.2 times V1. Very good. According to the equation number 1, V2 is 1.2 times V1. So instead of V2, let me write 1.2 times V1, and here I have square. V2 square. V2 is 1.2 times V1. Square should be written as square. Minus V1 square, like this. Okay, now can you do the rest and find V1, because all the other terms are given. All the other terms are given. So can you find the value of V1? Somebody please tell me what is the mass of the aeroplane. Sometimes you may have forgotten. Somebody check the Tute and tell me the what is mg mass of the aeroplane here? Total mass of the aeroplane. Lamai?
2.64 into 10 to the power 5.
64 into
2.64.
2.64. Sorry, 2.64 into 10 to the power
5.
10 to the power 5 kilogram. G is 10. Divided by what is the cross section area of both wings? It's given. The cross section area of both wings.
250.
250 equals half. Let me write the half like this, and it will be much easier to simplify. Half into what is density of air?
1.20.
1.2 into what is square of 1.2, dear? What is square of 1.2?
1.44.
1.44, and here we have 1.44 V1 square minus we have this V1 square. So without writing just V1 square, is it okay if I write like this? Sorry. Here we have V1 square. Without writing V1 square, is it okay if I write like this? Is it okay if I write like this? 1 into V1 square. Is it okay or not? Lamai?
Okay, sir.
Okay, sir.
If I write it like this 1.00 V1 square, is it okay or not?
Okay, sir.
It is still okay, because 1.00 mean 1. 1 into V1 square is V1 square, no problem. So once you write like that, this 1.44 V1 square minus 1 V1 square means actually 0.44 V1 square. Okay, now try to do the rest and find V1, dear. Give a try. V1 is the velocity of the aeroplane, and it is the velocity of the air at the point X. Please do the rest of the simplification. Find V1 and send your answer to my Zoom chat here. Start. If you have found the value of V1, please send your answer to my Zoom chat, dear. Okay, 2 students have sent me the answers. What about others, dear? Try, dear. Send your answer to my Zoom chat. Right. Let me check. It's not so difficult. This 2.64. This 2.64 can be converted in 264 if I take 2 zeros from this. Right? If I take 2 zeros from this 10 to the power 5, this can be converted into 164. It will be 264. Then 10 to the power 5 will be 10 to the power 3. This will be 10 to the power 3. And the other 10, this remaining 10 will be as it is. Right? And divided by 250 will also be there. Equals, if I consider this side, this 1.2 and this 2 can be divided. 1.2 divided by 2 is 0.6. 0.6. Am I right, dear? Into 1.44 minus 1 means 0.4. 0.44 into V1 square. V1 square. Now again we can simplify like this. This 10 to the power 3 means 1000. 1000. 1000 divided by 250. Can somebody tell me? Nothing will happen to this 264. What is 1000 divided by 250? Lamai?
4.
Yes, very good. That is 4. Into 10 equals, here now we have 0.6 into 0.44. How do we simplify them there? 0.6 can be written as, look at board, I can write 0.6 as 6 over 10. And 0.44 can be written as 44 over 100. Is that maths clear for you? I have written 0.6 as 0.6 as 6 over 10. 0.44 is written as 44 over 100. In addition, we have V1 square. Now you see that this 10 and this 100 can be taken to this side by cross multiplication. So they will be going to that side up, and 6 and 44 go to the bottom. So let me write it like this, 264. We move this little bit up, right? 264, this into 4 into 10 into this 10 and 100 terms comes here. So that will be 10 into 100. And this 6 and 44 should be written here. 6 over 10 will be 10 over 6. 44 over 100 will be 100 over 44 when the terms are taken to the other side. So here we have only V1 square. Now you see the difference. This 4 and 44 can be written, then you will get 11. Am I right, dear Lamai? Hello?
Yes, sir.
Are you all with me?
Yes, sir.
All right. So can we divide this 264 and 4? What do you think? 26 divided by 6 is 4. 6 times 4, 24. 2 remaining. Yes. 264 can be divided by 6. So then let me write here. 264 can be divided by 6. 26 divided by 6 is 4. 2 remaining. Again, with this 4, it will be 24. 24 divided by 6 will be 4. 44. And into 4. This 4 will be there. Into 4. Into, you see this 10 into 10, 100. 100 into another 100. So how many zeros are there here? 10 into 10, 100. And there will be another 100. And the bottom, here we have only 44 because we have divided this 264 by 6. Here we have only 44. Now what will happen to this 44 here? The denominator 44, what will happen to it? Lamai? Why are you silent? What will happen to the the term number 44 in the denominator? Lamai?
Cancel, sir.
It will be cancelled out with this numerator 44. 44 and 44 cancelled out. So finally we will obtain that finally we will obtain that V1 square equals, we have 4 because 44 and 44 cancelled out. 4 into 100 into 100. 4 into 100 into 100. So what is this there? If V1 square is this, what is V1 there? Then V1 is the square root of this number. What is the square root of this number? 4 into 100 into 100. Lamai? Is it a very big thing there? Square.
2 into 10 into 10.
Very good. Square root of 4 is 2. Square root of the first 100 is 10. Square root of the next 100 is 10. So 2 into 10 into 10 means what is it there? That is 200. 200 meter per second. Complete it, dear. Who got this answer? Please raise your hand up if you have obtained this answer. Lamai? Please raise your hand up if you have obtained this answer earlier than me. Okay, very good. I'm so happy. Complete it, dear. Complete it. Write the answer. And once you have written all these things, send a message to Zoom chat saying done. Quick. Who wants more time to write these things? Is there anybody who wants any more time to write these things? Lamai? Please raise your hand up in the Zoom chat if you want any more time to write this. Right. If you want any more time, please take a screenshot. Then you can write it at home. If you want any more time to write these simplifications, please take a screenshot so you can write it at home. Right. Can somebody read the next part of the question, dear? Can somebody read the next part of the question?
The aeroplane starts at rest on the runway and applies a constant horizontal driving force of 6 into 10 to the power 6 Newton from its engines. If the average drag force due to air is 7.20 into 10 to the power 5 Newton, how far does the aeroplane have to travel along the runway in order to achieve the speed v, calculated in part Roman number 2 see above?
Okay, thank you very much, dear. Thank you very much. They ask us to find the time taken and the distance that the aeroplane should travel to obtain this 200 meter per second velocity. Aeroplane should obtain a velocity of 200 meter per second. For it to just lift off the ground, to leave the ground and fly into the sky, it needs a velocity of 200 meter per second. So they have given us some data. I'll erase this, right? It's not erased. Right. Listen, dear. They have given us some data. Let me draw the aeroplane roughly. Right. So let me consider this as the aeroplane, if you don't mind. I cannot draw any wings. Right. So let me draw the aeroplane like this. So this is my aeroplane, right? Now, what is the force? What is the size of the force given by the engine, dear? Please, somebody unmute the mic and tell me. Force given by the engine of the aeroplane.
Six into 10 to the power 6.
So did you speak loudly? 6 into, I didn't hear it properly.
6 into 10 to the power 6, sir.
6 into 10 to the power 6 Newton. Am I right?
Yes, sir. Yes, sir.
Right. This is the force given by the engine. In addition to the force given by the engine, right? Let me mark it like this. The force given by the engine is this. 6 into 10 to the power 6. There is an oppositely directed force, that which is known as air drag. What is the air? What is the size of the air drag there? Air drag means some kind of a friction force which is given acting against the motion. It is 7.2 something into 10 to the power
5.
10 to the power 5. So the force given by air against the motion, it's not if air. Let me mark it like this. If air is, that is 7.2 into 10 to the power 5. Am I right there?
Yes, sir.
So what is the mass of the aeroplane?
2.64 into 10 to the power 5.
Mass of the plane is, yes, 2.64 into, am I right?
Yes, sir. 10 to the power 5.
10 to the power 5 kilogram. Please draw this figure, dear. Please draw this figure. by using this diagram, we can find the acceleration of the aeroplane. That's what I'm going to do. Draw it there, please. Right now, let us apply F equals ma equation. Let us apply F equals ma equation. Right. So there are two forces acting on the aeroplane, right? So FENG, force given by the engine, try to move the aeroplane to the forward direction. The force given by air drag force, try to stop the motion of the aeroplane. So the resultant force acting on the aeroplane into the moving direction is FENG minus FAR. Is it clear for all? Right, so FENG, the mass is m, acceleration is the thing that we want to find, right? So FENG is given as 6 into 10 to the power 6, and drag force, the resistance force given by AI is 7.2 into 10 to the power 5 equals mass of the aeroplane is 2.64 into 10 to the power 5. Sorry, 10 to the power 5. Acceleration is A. That's a very easy method to simplify this. Let me show you here. So here I have 10 to the power 5. Here also I have 10 to the power 5. It's better to have 10 to the power 5 here. Then I can cancel out all the 10 to the power 5 terms. Because here I have 10 to the power 5. Here also I have 10 to the power 5. Here I have 10 to the power 6. So I want to convert this 10 to the power 6 into 10 to the power 5. The method is this there. I can take one of the zeros to this side and I can make this 6 into 60. So it is 60 into 10 to the power 6 will be 10 to the power 5 minus 7.2 into 10 to the power 5 equals 2.64 into 10 to the power 5 into A. Right? So then this 10 to the power 5, this 10 to the power 5, this 10 to the power 5 cancelled out. So the remaining terms will be 60 minus 7.2 equals 2.64 into A. Can you do the rest and find acceleration, dear? Give a try, dear. Try to do the rest of the simplification and try to find the acceleration. Try, Lamai. Right? Still only one student sent me the answer. What about the others? Find the value of the acceleration and send your answer to my Zoom chat. I'm waiting for you. Okay, now other students also sending me the answer. I'm so happy. Right, look at board here. 60 minus 7.2. 60 minus 7 will be 53.2 mean 52.8. So this is 52.8. The other side I have 2.64 into A. So if I take 2.64 to the other side, A can be subjected. So then simple A is equal to 52.8 divided by 2.64. So actually this is something like 528 divided by 264. If 528 divided by 264, it will be 2. But there are decimal places. Therefore, if you divide this, you will get 20. So A equals 20 meters per square seconds. Who got this answer? Please raise your hand up in the Zoom chat. Right. If you have obtained this answer earlier than me, please raise your hand up. Very good. Nice. Excellent. Now they ask us to find the distance or time there. I don't remember. Do they ask distance or time? Time taken for the aeroplane to achieve the velocity or distance that the aeroplane should travel to achieve the velocity. Lamai?
Distance, sir.
Distance, right. So if they ask us to find the distance, actually the aeroplane starts to move at rest. Aeroplane starts to move at rest. It means u equals 0 and final velocity should be 200 meter per second. Acceleration we have found it as 20 meters per square seconds. Right? That's all. So we want to find the distance traveled by the aeroplane. Very easy. I can apply the equation u square, sorry, not u square. I can apply the equation v square equals u square plus 2as. So final velocity is 200. I should get the square of it. Initial velocity is 0. I should get the square of it. Plus 2 into acceleration is 20 into displacement is s. Can you do the rest and find displacement s and send your answer to my Zoom chat? Start there. Find the displacement s and send your answer to my Zoom chat. S is in the unit with the unit of meters. Try there. I think you have obtained the answer. Time is enough. 200 square is there. 0 square is 0. What is 2 into 20? So it can be written something like this. Look at board here. Can you hear me? Lamai, can you all hear me? Hello?
Yes.
Yes, sir.
Right. Listen dear. 200 square can be written as 200 into 200. 0 square is 0. I don't want to write it. So I have 2 into 20 into A. Sorry, into S. Now I'll take this 2 into 20 to the other side. So 200 square is written as 200 into 200. It's fair. It's correct. So then I have 200 into 200. 2 into 20 will be there. 2 into 20 will be there. Equals S. Now you see that this 200 can be divided by 2. 200 can be divided by 2. What is 200 divided by 2? Lamai?
100.
100. Very good. Then what is 200 divided by 20? 0, 0 cancelled out. 20 divided by 2. That is 10. Am I right?
Yes, sir.
Yeah. Therefore, S is very good. Therefore, S is 1000 meter. Or if you want, you can write 1000 meter means 1 kilometer. Who got this answer? Please raise your hand up in the Zoom chat if you have obtained this answer earlier than me. Okay, very good. Excellent. It's completed there. While others write in the answer, can somebody read the next part of the question? Next question. While some students are writing the answers, if you have already obtained this answer, can you read the next part of the question? Next question, please.
The cross-section of a wing of the aeroplane which is moving 10 degrees to the horizontal just after takeoff is shown in the figure. Copy Roman number 1. Copy the cross-section of the wing onto your answer paper and draw the direction of the net force acting on the wing due to the pressure difference between the bottom and top of the wing.
Right, let's give a try. So if you want any more time to write these things, please take a screenshot there. Please take a screenshot if you want any more time to write these things. Right. Now let's give a try for the next part of the question. Yeah. This. But this is not the correct question page. This question is here, but this is 97, 98, 99, 2000, 2001, 2002, 2003, 4, 5, 6 years. Right, but 6 we have completed those things. We have answered up to simple D. Am I right, dear? Can you see the question?
Yes, sir.
We have completed up to simple D. A, B, C, D, everything completed. So let's go to the next page. Right. Here, this is the question. So they have given us a cross section of the wing. The cross section of a wing of the aeroplane, which is moving 10 degrees to the horizontal, just after takeoff is shown in the figure. Copy the cross section of the wing onto your answer paper and draw the direction of the net force. Direction of the net force acting on the wing. Net force acting on the wing due to the pressure difference between the bottom and the top surface. They ask us to draw the direction. So simple. So the point is the pressure force is always acting towards the surface and perpendicular surface. Therefore, the pressure force acting on the bottom surface acting towards the bottom surface, and the other force also acting towards the surface. And if you want, you can draw a line like this, right? And you can draw another line like this. The two forces should be acting on the same straight line, the two forces should be acting on the same straight line like this. They should be acting along the same straight line like this. And this angle will be 10. So you can resolve the force into this direction. F1 cos theta, F2 cos theta, and upward force is acting along this line. So resultant force can be marked like this. That's all. The resultant force acting vertically upward. Draw the figure. They ask just draw the direction of net force acting on the wing due to this one, vertically upward. That's all. Right. So this is, as I remember, that is F2. The force acting on the upper surface, as I remember, it is F2. Force acting on the bottom surface, that is F1. Right. The net force is F1 cos theta, F2 cos theta this direction, F1 sin theta to other direction, F2 sin theta other direction. So it means the net force should be acting vertically upward. That's why it is moving up. Draw this diagram, dear, quick. When you draw the diagram, no need draw these arrow lines. You see these black color lines, they are just these lines are just air. Therefore, no need to draw these lines, right? They are they wing airflow. So no need to draw the airflow lines. Just draw the wing and mark the F1, F2 force and the net force. That's it. Yeah, yes. Even mg force should also be there. Mg force is acting vertically up downward like this. Yes, why not? Mg force acting downward. The green color two arrows show you the resultant upward force. Draw the diagram here, quick. Who wants more time to draw the figure? May I go to the next question, Lamai? If you want any more time to draw the figure, please raise your hand up in the Zoom chat. Even a single student wants any more time to draw the figure, please raise your hand up in the Zoom chat. Okay. Right, let me go to the next part of the question. But if you want any more time to draw the figure, please take a screenshot. Right, now what they have asked. Now the speed of air over the top surface of the wing relative to the aeroplane has increased 250 meters per second. Assuming that the airflow bottom surface of the wings relative to the aeroplane remains the same in Roman number 2. So bottom surface, the velocity of the wing going along the bottom surface remains unchanged, that is 200 meters per second. Speed of air over the top surface of the wing relative to the aeroplane has increased to 250 meters per second. Assuming the speed of air below the bottom surface of the wings relative to the aeroplane remains the same. Calculate the vertical lifting force acting on the wings now. So simple, dear. What is the vertical lifting force acting on the wings now? Let me use the previous equation. Right, I think we have obtained this equation earlier. We have obtained the equation mg divided by capital A equals, do you remember this equation? Mg divided by capital A into a half into rho into V2 square over V1 square. Am I right, dear? Lamai? Okay, you don't remember. Nice, excellent. At least do you remember this equation? P1 minus P2 equals, do you remember this equation at least? Half into rho into V2 square. V2 square minus V1 square. Do you remember that equation at least? The first thing that you want to do is, right, they have given half is known, P is, this rho is known, V2 is given as 250, V1 is given as 200. From this, you should be able to calculate P1 minus P2. Find P1 minus P2, dear, quick. Find P1 minus P2 and send your answer to my Zoom chat. Start. Please don't be lazy, try to do it, right? Rho is 1.2, V2 is 250. You must obtain the square of it, minus V1 is 200. You should obtain the square of it like this, right? 1.2 divided by 2 is 0.6 into 250 square minus 200 square. So this is the, you can write it in O-level maths. This is something like x square minus y square. If square minus y square means x plus y, it means 250 plus y is 200. And x minus y, x is 200 minus y is 200, 250 minus 200. Like that, you can find this easily, right? If you have any doubts related to this simplification, please ask, I can help you. I used O-level mathematical equation. This term is 250 square minus 250 square minus 200 square is very similar to x square minus y square. So this is 0.6 into 200 plus 250 means 450 into 250 minus 200 is 50. So I'm not going to simplify this any further. If you want, I can write one more step. 0.6, listen here, 0.6 can be written as 6 over 10. Let me write one more step, 6 over 10. So I can cancel out this 0 and this 0. See the beauty? This 0 and this 0 can be cancelled out. The remaining terms will be 6 into 450 into 5. I'm not going to simplify anything further, so I leave the answer like this, right? So but in the exam you should divide it, so I'll keep it somewhere here. Just write them quickly, dear. Right, so it is said that 13,500 Pascal. Is it correct, dear? Kamal? Is it 13,500 Pascal? P1 minus P2?
Yes, sir.
Yes. Okay, I'll erase it. I think you have obtained the answer. Now, they ask us to find the net lifting force. It's so simple. Look at board, dear. Look at board. If this is 10 degree, you can complete this line. Wait, let me complete that line like this. So then this should be 90 degrees. This is 90, this is 10, all together should be 108. Therefore, this should be, what is this angle here? What should be this angle then? This is 90, this is 10, 100. So this should be 80 degrees. This should be 80 degrees. And all together, this should be 90. It means this angle should be 10 degrees. This angle should be 10 degrees. If it is 10, this angle should also be 10 degrees. This angle should also be 10 degrees. So what is the net lifting force there? They ask us you to find the net lifting force. The net lifting force will be F1 cos 10. F1 cos 10 upward, mg and F2 cos 10 acting downward. So let me write it here. Therefore, the net lifting force should be F1 cos 10 upward force minus the summation of the downward forces. The downward forces are F2 and downward component of F2 is cos 10. F2 cos 10 summation of the downward forces mg, right? So you have to simplify, right? So you simplify this at home and send your answer to my WhatsApp. That's the best thing. You simply, because you know that F1 is, listen here, F1 is P1 into cross section area A, and in addition you have this cos 10. So it will be a very big simplification. So at home, and if you remove the brackets, again F2 means P2 into cross section area A into cos 10. If you remove the bracket, this will be mg. So you simplify this at a home and send your answer to my WhatsApp. Okay, dear? Namai?
Okay, sir.
Right. Write these things and I'll you can send your answer to my WhatsApp within this week. Try to do the rest of the question at home. Send your answer to my WhatsApp.